Hi to all. My name is Dejan Savovic, and I will present to you today SQL Server 2019 Intelligent Query Processing. A little bit about me. I'm a senior database developer in Zagreb in Croatia in Span, company called Span. I love performance tuning and troubleshooting. I'm a Microsoft certified trainer and co-organizer of SQL Saturday Croatia, which will be held in September of 2021, and co-organizer of past meetup SQL Server User Group Croatia. Here you can see my contact details, my email. So if you want to reach out, I'll be happy to answer to all your questions. You can find me on LinkedIn, on Twitter, on Facebook. So feel free to connect. Today's agenda is all about intelligent query processing, which is a combination of features of SQL Server 2017 and 2019. And that includes adaptive joins, memory grant feedback, interleaved execution, table variable deferred compilation, batch model row store, TSQL, Scalar Udf Inlining, and approximate query processing. I will talk about each of these features of intelligent query processing, and after each of them, I will have a brief demo about them to show you how it works, how it handles in action. So this is the map of intelligent query processing features, which, as I said, include adaptive query processing from SQL 2017 and 4 additional features from SQL 2019. 3 of them are enterprise edition features only, and those are adaptive joins on batch mode, memory grant feedback, and batch mode on roster. All others work in all editions of SQL Server, and like table variable deferred compilation, this Scalar Udf Inlining, and so on. SQL Server 2019 for memory grant feedback added row mode as a means of execution for memory grant feedback. In SQL Server 2017, we only had batch mode for memory grant feedback. So let's go further. So as I said, 3 of 7 enterprise edition features only. And you have to know that 6 of 7 features can affect your existing code. So if you migrate from SQL Server 2016, for example, to 2017 or 2019, some features can affect your existing code. And if you migrate to SQL Server 2019, you should be aware when you update your database compatibility level to 150, all features in intelligent query processing are activated by default. This is something you have to know. And one feature, SQL Server user-defined function inlining, does not work in SQL Azure, in managed instance or SQL Azure database. How does intelligent query processing affect your queries? Well, it will affect your queries if you have table variables in them, user-defined functions, multi-table valued functions, if you have complex queries or table with skewed data distribution. For example, if your queries sometimes need hash or nested loops joins and they make inappropriate operator choice, a feature called adaptive join will help to resolve this problem. Issues like memory grant under or overestimation also is handled in SQL Server 2017 in batch mode and SQL Server 2019 in batch mode and row mode. So this is handled by SQL Server. In SQL Server 2016 and prior, all planned decisions are made at compile time, meaning that once the execution plan is created and cached, you cannot change it. SQL Server cannot change it. It changes only if you remove it from cache, or SQL Server, because of memory pressure, removes it from cache and creates a new plan that is stored in the cache. In SQL Server 2017, you have something called multi-statement table valued function interleaved execution, which enables SQL Server 2017 to know the exact number of rows which are coming from the multi-statement table valued function. You have adaptive join in batch mode only, which is also in batch mode in SQL Server 2019, which enables SQL Server to, at runtime, choose from nested loop or hash join. We will talk about that later. And you also have memory grant batch feedback, which is in SQL Server 2019 available in row mode also. Additional adaptive improvements in SQL Server 2019 are table variables. SQL Server defers compilation of table variables and thus enables it to know the exact number of rows that are in the table variables. And important feature is also TSQL inlining, which enables SQL Server to execute the TSQL Scalar user-defined function as a set-based function. I talked about SQL Server 2016 and prior and said that there are no planned changes for cached execution plans. In SQL Server 2019, this is possible. And in SQL Server 2017, with memory grant feedback, which enables SQL Server to change the memory granted to the SQL to the query and make the query run either faster if it was an underestimation, or reduce the memory granted if the case was that it was overestimated in the first run. Let's talk now about adaptive joins. They are available in SQL Server 2017 and 2019 in batch mode only. Basically, SQL Server, as you can see in this picture on the slide, in the runtime, chooses whether to execute adaptive join operator as nested loop or hash match. So for this to be possible, the inner table coming into the adaptive join operator has to be accessed by a column store index. And if that happens, then you can have adaptive join that in runtime chooses whether to go to this branch, which is a hash match branch, or nested loop branch, which is branch number 4. The decision is made based on the adaptive row threshold, which is calculated at compile time of the execution plan and stored with the adaptive join operator. So if the number of rows coming from the first operator is greater than the adaptive threshold rows, then the SQL Server will go into hash match. So adaptive join will transform to hash match, and it will go to the third branch and execute the hash match. And if the number of rows coming from the first operator is less than adaptive threshold rows, then it will go to the nested loops. This applies only to select queries. This feature of SQL Server handles oscillations in number of rows coming from the first branch. And there is obviously some overhead, but it is in the end there is a benefit because we are getting the correct join operator, hash match, or nested loop. Now let's see how this works in action. So first, I'm doing this on the SQL Server 2019. on Wide World Importers database. And I will take this database into compatibility level 130, which is compatibility level of SQL Server 2016, just to show you different joins that are available. So let me include actual execution plan, execute the query, and you can see here a nested loop join being used to join the tables. In the next example, we will see merge join in action in the execution plan. See it here. And in the last example, hash match join to join the tables that are in the query. Now let's go and see how adaptive join works. So first of all, let's set statistics time to on and drop and create a non-cluster column store index on sales order lines to make sure we are in batch mode. Okay, now I will create a store procedure get order details that has unit price as the input parameter, and which in the store procedure there is a select query that joins sales order lines and sales orders, and where predicate on unit price on sales order lines, which equals to input parameter of the store procedure. First of all, let's set batch mode adaptive joins to off. You can do this with this statement. And let's clear procedure cache of the database and execute the get order details with value 112. So unit price of 112. And include the actual execution plan. In the actual execution plan, we see that these two tables are joined with hash match. Now let's execute this with value 36. And because the execution plan is stored in the execution plan cache, we get the same execution plan. Sorry, let me repeat this quickly. Did I execute this? Okay. So I got something that was not expected. So let's execute this with 112. We get a hash match and execute this with value 36. And we again get the hash match because the execution plan was stored in the execution plan cache, and SQL Server has retrieved this plan from the query plan cache. Now let's reverse the order of the execution of the store procedure. First of all, let's clear the procedure cache. Now we are executing with unit price 36, and now we get that the execution plan for value 36, it is better to run with nested loops. But when we run it with 112, we don't get hash match. We get again nested loops, and this is a problem. So for different values of input parameters, we get different needs of SQL Server for a join operator between two tables. And SQL Server 2019, when we set batch mode adaptive joins to on, and let's clear the procedure cache. Let's execute this with 36 now. Now we in execution plan get a new operator, adaptive join, which in this case has adaptive threshold of rows 191.49. And you can see here estimated join type is nested loops and the actual join type is nested loops. Let's see number of rows coming from this operator. It's 33, so it is below the adapted threshold of rows. And because of that, SQL Server goes into this branch and executes adaptive join as nested loop join and executes this query with nested loops. Now let's run this with 112. And we can immediately see by this thick arrow that adaptive join went into hash match and executed this branch to satisfy the hash match operator. So you can see this here. Estimated join type is hash match. Actual join type is hash match. And this way, SQL Server is handling oscillations in the number of rows coming from this operator. Okay. Let's go further to memory grant feedback. In SQL Server 2017, as I already said, this works only in batch mode, and in 2019 works in row and batch mode. And this feature enables SQL Server to adjust memory after it was first executed, and SQL Server knows that on the first execution or subsequent executions, there was an overestimate or underestimate of rows. In the second execution, SQL Server will adjust that granted memory. It will decrease it or increase it. You can imagine that with this memory increase and memory decrease, you can go into a fluctuation and into a loop with increase and decrease following each other. But this will be disabled after some number of increase and decrease fluctuations happened. Let's see this in action. So memory grant feedback. Let's make sure the wide world importers is in compatibility level 150. Let's clear the procedure cache. Let's bring in the properties window. We will need it. Include the actual execution plan and execute this query, which is joining purchase orders and purchase order lines. Okay, in the execution plan, we see this exclamation mark on the select operator, which has a warning and says the query memory grant detected excessive grant, which may impact the reliability. Grant size initial is 23 megabytes and used is only 120 kilobytes. So we have an overestimate. And if we take a look at properties of select operator in the memory grant info section, we see is memory grant feedback adjusted. It says no first execution. If we execute this again, now we don't see the exclamation mark on the select operator. And in memory grant info, we see is memory grant feedback adjusted. Property says yes, adjusting. Okay. And if we execute it again, this shouldn't have happened. It says now no first execution. I was expecting yes, stable, but this happens. Let's run it again. Okay, and let's run it again. Okay, now it says yes, stable. Let's go to interleaved execution feature of the intelligent query processing set of features, which works on SQL Server 2017 and 2019. And this feature actually enables SQL Server Query Optimizer to pause the optimization, execute the multi-statement table valued function, capture the accurate cardinality of the multi-statement table valued function, and resume optimization. This way, SQL Server knows the exact number of rows coming from the multi-statement table valued function and has the ability to make a better execution plan. This also applies to select only queries. And you know that for multi-statement table valued function, cardinality was fixed to 100 from SQL Server 2014. And prior to that, it was fixed to number 1. So let's see this in a demo. Okay. I will create a significant orders function, which inserts into defined table T sales orders, order ID from sales orders. Very, very simple function. And now let's execute this in compatibility level 110, which is SQL Server 2012, and include actual execution plan. And we can see in the execution plan that estimated number of rows to be read is 1, and the actual is 73595. In compatibility level 120, which is SQL Server 2014, the estimated number of rows is, as I said, 100, and actual number of rows is 73595. And if we set this to SQL Server 2017, then SQL Server kicks in with a new feature, and we get an estimate which is completely accurate. So it is exactly the same as the actual number of rows being read from this multi-statement table value function. This is a very simple multi-statement table value function, but this is just to show you how this works. And now let's see this when we join this to some other tables. Let's again go to SQL Server 2012 and execute this query where I'm using sales order lines and joining this to significant orders for package type 7. Sorry, I forgot to include the actual execution plan. Okay. We see now in the plan that we have an estimate of 1, and the actual is the same, 73595. And we have, because of this estimate, a nested loop operator. This plan will be the same for the 120, so I will skip it and go directly to the 2017 SQL Server and show you the execution plan. Okay, we have our multi-statement table value function here. The estimate is accurate. exactly the same as the number of rows being read from the multi-statement table value function, and because of this estimate has improved, now we see hash match join and not the nested loops anymore, and the complete plan has changed basically because of this improved cardinality estimation. Multi-statement table valued function interleaved execution has some limitations. Limitation is that you cannot have changing parameter for each row like in this join, where I'm joining sales customer with multi-statement table value function called top 2 orders for customer and passing in a customer ID. This function is created here. I have an input parameter of customer ID and selecting top 2 orders for this customer. So if you do this, let's see how this behaves. Let's include actual execution plan. And now you can see that the estimate has dropped down to 100 and the actual number of rows is 1326. So this is the limitation of the interleaved execution feature of SQL Server 2017 and 2019. Next feature is table variable deferred compilation, which works only in SQL Server 2019. And deferred compilation means exactly that. Compilation of a table variable is performed by SQL Server Query Optimizer when the table variable is used in the query. So this way SQL Server knows the exact number of rows in the table variable. This doesn't add new column statistics, it doesn't increase recompilation frequency. And what about the variations in table variable cardinality? Well, here you have the same problem as you have with any other input parameter, for example, in stored procedure. So you are prone to parameter sniffing, and this could be beneficial or this could be a problem, and you can deal with that in various ways. Let's see this in a demo. Okay, we are still on the wide world importers database. Let's go into the SQL Server 2017 compatibility level and declare the table variable as stock item ID integer. Insert from warehouse stock items into this table variable and join it with a couple of tables. So let's execute this. It's still executing. Okay, it's finished. And we can see that here is the operator accessing the table variable. We can see that the number of rows to be read estimated is 1 and the actual is 227. Now let's go to the compatibility level 150. And now execute the same query. It has executed much faster. No, it's still executing, sorry. But it's finished much faster. And now we have an estimation of 227. and actual is 227. So this is because SQL Server Query Optimizer has deferred the compilation of this table variable to this statement. And now it's compiled, and this way SQL Server knows the exact number of rows from this table variable. Next feature is Scalar Udf Inlining, which works only in SQL 2019. And we all know that the old way was iterative invocation. There was lack of costing in the execution plan that we could see in the Management Studio. This was an interpreted execution, and there was no way for SQL Server to run this query in parallel. So it was always a serial plan. New way, SQL Server transforms Scalar UDFs into relational expressions. This is set-oriented, and it can be run in parallel with some limitations, but in most cases it can do this. Let's see a demo of this. Just a second. Sorry about this, I will have to skip this demo, but in fact, in execution plan, you can now see the Scalar UDF function not as a black box, but as a real operator with costing. Sorry about this. Next feature is batch mode on row store, which is available on SQL Server 2019. It enables SQL Server to run queries in batch mode without column store indexes. And some scenarios where this would be beneficial are analytical queries on OLTP DB which are CPU bound, and if there is too much overhead to add to your OLTP DB to add column store indexes. Operators that support this are hash join, hash aggregates, sorts, window aggregates, filters, concatenations, and compute scalar. And limitations are that this feature is available only for disk-based tables and indexes, so in-memory tables are not supported yet. And if you have LOB, sparse column sets, and XML, this does not work. Let's see this in a demo. So batch mode on row store. Let's include statistics time on and go to the compatibility level of SQL Server 2017 and include actual execution plan. If we run this simple query, which counts rows from cold room temperature archive, we see in the execution plan that this is actual execution, and estimated execution mode is a row, as you can see it here. And this query executed in 1.466 seconds. If we go to compatibility level of SQL 2019, where batch mode on row store works, the same query runs in 500 milliseconds. And in the execution plan, you can see that now we have batch mode. Let's now use the group by to group on a column in this same table and count the records. in the compatibility levels of SQL Server 2017. And this ran for 2.1 seconds. And in the execution plan, you again see that it is in raw mode. And if we do this in SQL Server 2019, it ran much faster. It ran in 683 milliseconds. And in the execution plan, you can again see that it is running in batch mode. Now let's use a little bit complex query. Not so much complex, but it includes row number with partition and order by, and we are selecting only the rows with row number that is greater than 1 in compatibility level of SQL Server 2017. The query didn't return any records, and it ran for almost 4 seconds. And in compatibility level of SQL Server 2019, the same query will run in batch mode, and it will run in under 1 second. Okay, so it is faster than raw mode. And now let's go to approximate query processing, which is a feature of 2019 SQL Server. And this is the only feature that does not affect your existing code, because to use this feature, you have to use the new function approx count distinct, which guarantees up to 2% error within a 97% probability. So it gives us a way to much faster with less used memory to return approximative value of count distinct of a column in a presumably large table. So let's see this. So I will include actual execution plan, put the database into compatibility level of SQL 2019, and execute these both queries at the same time. So the first one executed in 800 milliseconds, the second one in 672 milliseconds. And what I wanted to point out is that the first query using count distinct used 423 megabytes of memory. And the second query used only 33 megabytes of memory. So much less. But at the cost of giving the incorrect result or approximative count distinct result. So these are all of the features that I wanted to talk about in intelligent query processing set of features. Keep in mind that those features can have regressions in your existing code. It can also have improvements. But I would like to point out that you need to test if you are moving or migrating from SQL Server 2016 to 2017 and 2019, and see if you have any regressions. Do we have any questions, maybe? No? Okay, then thank you for your attention, for attending this session, and keep learning.